In this video, we will learn everything we need to know about lines. First, let's look at how an equation of a line is like. The equation of a line is defined as y equals mx plus b, where x and y are the coordinates of the points on the line, m is the slope of the line, and b is the y-intercept. Because this equation includes slope and intercept, it is called the slope-intercept form of a line. We have already discussed what a y-intercept is in our previous video. It is the point where the line crosses the y-axis. Let's see what the slope of a line means. The slope of a line measures how steep the line is. The slope increases as the steepness of line increases, and the slope decreases as the steepness of line decreases. The slope of a line can be measured using any 2 points on the line. The table shows the Cartesian coordinates of these 2 points, say P1 and P2. The slope of the line can be defined as the ratio of the height of the line to the width of the line. This is also called the rise over run. Mathematically, the slope of a line can be calculated as the difference between the y-coordinates of the 2 points divided by the difference between the x-coordinates of the 2 points. Plugging in the values of current points, we get the slope of the line as 1. One interesting thing to note is that the slope of a line is the same no matter which 2 points on the line are chosen. Whether the points are far apart from each other or close together, the slope of the line remains the same. Slope is an important concept in geometry. There are many interesting properties of lines that can be understood using slope. For example, we can determine if 2 lines are parallel by looking at their slopes. 2 lines are parallel if their slopes are equal and they have different y-intercepts. This is how 2 parallel lines look like on a graph. If lines are not parallel, they are bound to intersect at some point. This is the same as saying that the slopes of the lines are not equal. You might have heard that 2 parallel lines never meet. This is because they have the same slope and therefore they will never intersect, no matter how far they are extended in either direction. The slope of a line can also be used to determine if 2 lines are perpendicular to each other. 2 lines are said to be perpendicular if their slopes are negative reciprocals of each other. This is how 2 perpendicular lines look like on a graph. When 2 lines are perpendicular, they form a right angle at the point where they intersect. Also, since their slopes are negative reciprocals of each other, the product of their slopes is equal to -1. Recall in the previous video, we looked at how to plot any graph for a 2-variable equation. But sometimes, we might not have the equation of the line, but instead all we are given is a point on the line and the slope of the line. In such cases, we can use the concept of slope to plot the line. Let's say we have a point with coordinates 2, 3, and the slope of the line is 1/2. We start by first plotting the point on the graph. Next, we draw a horizontal line of length 2 from the point, which is the run. And then from the end of the horizontal line, we draw a vertical line of length 1, which is the rise. The end of the vertical line gives us the coordinates of the second point on the line, which is 4, 4 in this case. Finally, we draw a line connecting the 2 points on the graph. You might be wondering if we can find the equation of the line using the slope and the point on the line. The answer is yes. Recall the point slope-intercept form of the line equation we discussed in the beginning of the video. We can plug in the value of slope in the equation as it is known to us, but we still don't know b. which is the y-intercept. Now there are two ways we can find the value of b. One way is to graphically extend the line such that it intersects the y-axis. The y-coordinate of the point where the line intersects the y-axis gives us the value of b. The other way is to use the equation of the line by plugging in the coordinates of the point on the line and solving for b. Finally, by substituting the value of b in the equation, we get the equation of the line. That's all for this video. I hope you enjoyed learning about lines. Let us know in the comments if you have any questions. In the next video, we will look at circles and how to graph them. Thanks for watching.